My name is Rich Stromberg, and I am the Wind Program Manager for Alaska Energy Authority. And this session is on advanced metering with a focus on rural systems, but not exclusive to that. Everything we're going to talk about here could be applied to rail belt systems here in Alaska as well. We have three great speakers here on a good range of topics here. First, we're going to start off with Jim Verlare, and he's a solutions architect for Elster Solutions, and which is a provider of complete smart grid and energy management solutions for utilities, commercial and industrial customers and consumers. Before doing that, he was at doing IT and telecommunications at both Verizon and IBM. So, Jim, we'll let you take it away. And I think we have to use this one.
Okay, thank you, Rich.
There you go.
Okay.
And then it's the side.
Okay.
Advance.
Okay. All right. Great. Well, good afternoon, everyone. Really appreciate the opportunity to speak with you today. We're going to talk a little bit about advanced metering infrastructure today. Now, I come from Elster Solutions, and so obviously my presentation is going to be focused pretty heavily on our particular solution. And what we got here is this one is advanced to the right?
No, it's that.
Okay, right there. Okay. All right. So first of all, just a matter of a quick couple of introductions, and that is Scott Durham is our general manager. And so if you have any questions about the materials that we're covering today, you can contact me first of all. But then Scott, and then also we have our regional director here, Bridger Panela, and so welcome to him. In addition to myself, I've already been introduced. So today what I'd like to do is just give you a real quick introduction to our company, and then talk about Elster as a preferred rural AMI provider, talk a lot about the energy access solution that we have, and then also one of the things that comes up, especially in rural America, or rural Alaska, is the rural WAN considerations. So we're going to talk a little bit about the business case and what things to be looking at when it comes to your WAN topology. And then lastly, deriving value out of distribution network data. Elster, a very large AMI provider. We're one of the largest in the world. We have over 200 million meters installed in the last decade. We just recently won a very lucrative opportunity with ERDF out of France. That installation alone will be over 35 million meters. We are one of the oldest, coming from a heritage of Westinghouse and ABB, one of the oldest solution providers in this space. And again, very large organization, able to help you meet your metering needs and AMI needs, over $2 billion in revenue annually. What I'd like you to think about as we go through the presentation today, I'd like you to think about what does it mean to implement advanced metering infrastructure in terms of improving the customer service in your area? What does it mean in terms of improving the quality of service? So we'll look at baseline meter to cash, prepay, accurate real-time billing, remote service connect, disconnect. The second thing I'd like you to kind of think about, and that is gaining operational efficiency. What does it mean to really focus on reducing your visits? Theft tamper detection, and also rich distribution network applications. Those are the things we think about when we think about gaining operational efficiency. Low maintenance. Elster has the largest installed base in the world today of service-controlled disconnect switches. So to move to a paradigm where you're not constantly out and servicing locally in your villages, what does it mean to implement a full implementation of service-controlled disconnect switches? We also have a very diverse technology mix to address any obstacles you may have when it comes to WAN topology and technology. And so I'd like to spend a little time looking at that today. And then lastly, we have multiple deployment models. We can either have owner-operated models, or we can do a complete managed services. And we have one of our partners here today, Utilismart, and Gary, who will be speaking immediately after me, and he will talk to you about the managed services offerings. So what is advanced metering infrastructure anyway? For those of you who are maybe new to the terminology, it really starts with having a data collection system. I knew I would do that. The coordination of two is going to be a little fun. It really starts with having an overall head-end collection system, which is responsible for basically pulling in all of your meter data. You're going to have some type of a WAN backhaul to where the meters are actually located. And so at that point in time, you're looking at a whole diverse set of different WAN topologies and technologies that we may be able to deploy. And ultimately, you're getting down to the points on your distribution network, which are, of course, the intelligent metering points. Elster happens to be a true multi-utility provider, so we provide gas metering points, water metering points, and, of course, electric metering points. So when it comes to an AMI, the primary pieces essentially are your electronic meters, your gatekeepers, your LAN infrastructure, your WAN infrastructure, and then your head-end solution. Those comprise the basic elements of an overall AMI solution. Now, what these solutions are all about and the way that they're implemented is they're implemented in such a way as to understand the unique challenges we have with collecting data, in a world where we don't necessarily control the customer site. Right? And so it's not like you can just put in broadband connections to every site and collect information in that manner. And so we have alternate technologies that we would use in order to be able to get all of this meter data. Elster happens to, their primary solution here inside the United States anyway, is a mesh solution. It's a 900 megahertz radio network that brings all the meter data together to a collection point. We call those gatekeepers. And from the collection point, then we have a WAN technology that brings all that data back to a head-end system. And so the paradigm of this architecture is such that we're going out and we're pulling data in. So rather than sending data in, we're pulling data in. And the architecture is designed that way because of the intermittency of communications in these types of environments. So when you have intermittent communications, what you really want to make sure of is you're not going to lose any data anywhere. So the technology and the architecture is designed around this concept of non-volatile memory in meters, non-volatile memory in gatekeepers, ultimately so that we can keep X number of weeks or months of data in a meter, X number of weeks or months of data in a gatekeeper. And so if there's intermittent communications for any reason, we're not losing any data. It's just a longer lag time until we can actually pull that data. And that's why the entirety of the system is built around this concept of pulling data in. Right, so we call this distributed intelligence, where the meter is self-sufficient and on its own and collects all of that data. We can populate the meters, with intelligent information like TOU schedules, et cetera, and then, expect that the meter will be able to perform on its own until such a time where we go out and pull the data in. Whether that is, standard, billing, data, interval data, instrumentation data, et cetera. So we pull that information into a collector. Again, our terminology is a gatekeeper, and then ultimately bring it back into the head end. So those are the primary elements of AMI. Some of those that, as we advance in AMI, when you look at a solution provider, you're not just concerned about today, what am I doing today, with metering information, which mostly is a meter to cache type of an application. But you also want to make sure that that solution provider is providing you with a topology and a technology that's going to be able to grow as you grow. If you want to start to do low voltage transformer monitoring, if you want to bring in distribution automation, if you want to do any type of demand response programs. So our solution portfolio brings all those different types of applications to bear within the same infrastructure, same technology. So you're not investing in different technologies in order to accomplish some of those higher end applications as you grow your network. So what you see here is, again, the head end system. You're seeing the gatekeepers, which collect the information from the meters. And then you're seeing some additional elements out here, such as in-home devices and pluggable devices, in-home displays, etc., low voltage transformer monitoring, and of course your water meters and your gas meters and your electronic meters. So I mentioned that Elster's particular technology happens to be a mesh technology, a 900 megahertz mesh technology. This is really all about the economics, the ROI of developing and distributing a technology that's not overly expensive. And so a mesh technology, which is essentially unlicensed public spectrum at 900 megahertz, what happens is every meter acts as a repeater as well as a meter. And so they all talk to each other. And once they've all talked to each other, they will find a gatekeeper in their area. And upon finding that gatekeeper, they will register with that gatekeeper. They'll establish both a primary and a secondary path to that gatekeeper, so that if for some reason a primary path is interrupted, There may be some building construction, something is going on where that meter can't communicate in its normal path to other meters it may know about. And so it establishes multiple paths, to the gatekeeper. So all of that is about, creating this mesh of meters out there that can come to a collection point, right? In our particular case, we implement what's really referred to as a deterministic mesh. Mesh technology and what we call frequency hopping spread spectrum technology has been around for a very long period of time. There have been lots of implementations of this in different types of products in the marketplace. It's a tried and proven technology. But one of the things that we've really done with the technology is we moved from something that's an undeterministic type of a network where all the different points in the network in the mesh would be broadcasting and sending each other information to finding a way to register those endpoints with specific paths in terms of communication. So we call it a deterministic network. And so this type of frequency hopping spectrum technology is really good for keeping all the idle chatter down. So the only thing that you're really communicating then is the actual data that you want to pull out of the meters, right? Whether that's load profile data, whether it's instrumentation data, or simply register data that you're pulling back in from the meters, you're going through a deterministic network to bring it back to the gatekeepers. So that kind of gives you an idea of what things would look like in a undeterministic network where all the meters are chatting with all the other meters versus having a deterministic path where we find specific meters that we would talk to ultimately get back to a gatekeeper. So that just gives you a real quick visual of what that looks like. So how does that actually work? Well, when you first power up a meter, what's going to happen is it's going to broadcast, just like in an undeterministic network. It's going to say, hey, here I am, and find all the gatekeepers and find all the paths that are available. It's then going to look at the best signal paths that it can find and establish a primary path and establish a secondary path. And so all that's about, again, trying to build this deterministic network to keep chatter down to the maximum, to the minimum, and build out the network. So what pieces and parts are ultimately part of the AMI solution? We talked about a couple of those. So one of those I mentioned a moment ago is the gatekeeper. And the gatekeeper's primary responsibility is to pull that information in. It's to make sure that we synchronize all of the devices that are out there and keep network time amongst all those devices. The gatekeeper itself can be available in multiple forms. We can have that in basically a NEMA 4 enclosure, a ruggedized enclosure that can be put on a pole, or we can have it actually within an actual meter. And so the gatekeeper functionality lives actually inside an Alpha 3 meter, a commercial industrial meter, or it can live in a NEMA 4 enclosure, either or. We have another solution that I'm not going to really mention here today. We also have an IP access link router, but I think that that's for another time. There's another piece to the solution which is called a repeater. In those cases where you might have some meters that are too far away, and so when it comes to distance in mesh technology, we generally shoot for something around the order of a half a mile in distance between meters. If you're going to have greater than a half a mile to a mile between meters, then we would need a repeater in order to be able to take that signal to the next group of meters. And so we have a repeater in the solution as well. And the last thing that I had mentioned earlier was the low voltage AGI node. There are different ways to bring in information from, on the distribution network, to bring in information from all of your meters. If through provisioning you map all of those meters together, you can create virtual meters. But if you don't want to do that, you also have the opportunity to go ahead and put in low voltage AGI metering. And so we have, again, where to support that as well. Elster today, in terms of what you as a customer audience would be looking for, has 3 primary meters, which are our alpha meter, our commercial industrial meter. And that, again, very high end, up to 6 metering quantities, full 32 channels of instrumentation profiling, etc. We have our Rex 2 residential meter, the primary meter that you would be interested in within your villages of residential customers. And that has 2 energy quantities. And what we're moving to now is what we call our Rex universal meter. That is the same thing as a Rex 2, except we've expanded it to kind of bridge into the small business space. So we have 6 channels of instrumentation, but most importantly, it's a cellular meter as well. So in those locations where we just can't reach for some reason, we also have opportunity for what we call a direct connect. So we would bypass the gatekeeper and go directly to the head end with a cellular-based meter. And also, of course, the connect-disconnect. Just one mention on that, which is for when you're trying to service your customers and you're very remote, right? So you're not able to put feet on the ground to go do service. Remote connect-disconnect is a very, very important part of your overall solution. But it's also important, from the perspective that that solution shouldn't really look any different to your customer than any other solution. And so our remote connect-disconnects are within the meter, and you would not visually recognize, one meter from another meter, one that has disconnect, one that does not have disconnect. So there's no appreciable difference in terms of what they visually look like. So when you've collected all this information, from an AMI perspective and brought that information into your gatekeepers, brought that information now back into your head end, all that information has got to be processed, right? And now you're going to be integrating with other parts of your solution, principally your CIS system. But there's many, as you grow the system, there's many other implementations that you would be looking at as well, whether it's outage management system, VAR systems, et cetera. And so the solution, the head-end solution, has the opportunity to integrate with pretty much all the popular CISs and OMSs, et cetera. We do that all through a very robust set of web services, and those web services can be specifically unique to Elster in your particular implementation, or they can be multi-speed compliant, just depending on what you're looking for. If you already have a multi-speed compliant CIS system that you want to integrate with, we can support that. Rural WAN considerations. I mentioned at the beginning one of the things to be looking for, and that is how are you going to connect these gatekeepers, right, back up to your head end? So you've got very remote villages, so WAN technology is a very, very important aspect, for rural Alaska in terms of what choices you make to collect this information from your villages. I mentioned earlier that we have a gatekeeper that's under the glass. That can be a cellular gatekeeper. So with cellular becoming as pervasive as it is, and without you having to build out your own infrastructure for your WAN solution, portion of the solution, cellular is becoming more and more important all the time. And so our gatekeepers have internal cellular radios. In particular, the A3 alpha meter that can also be a gatekeeper can also be a cellular gatekeeper. And so again, without any appreciable difference, it's all underneath the glass, it's all encased within the meter itself. You have direct connect cellular from the head end as your WAN solution for A3-based gatekeepers. In addition to that, we have the ruggedized version I showed you just a moment ago. And in that ruggedized version, we've created essentially a universal type of a gatekeeper where you can put in a radio of your choice. So if you choose to put in a cellular radio, you can implement a cellular. We basically resell the Sierra GX440s. We also resell the General Electric 200 megahertz radios. So depending whether or not you want to go with public spectrum or private spectrum, or if you want to use basically cellular backhaul, we have all those options available with kits that you simply install those radios within the gatekeeper itself. That's kind of important when you look at these technologies, because when you lose power, you really want to keep that gatekeeper up and alive, because you don't know exactly where you're going to lose power. You could lose power throughout the whole village, or you could lose power on one line, and so you want to know, what's going on there. And so you want a gatekeeper that's battery backed up, and you want the radio for that gatekeeper to be battery backed up. And so, we've come up with this solution basically for our gatekeepers that allows you to implement whatever WAN technology that you choose, whether again it's private spectrum, 200 megahertz, GE radio, or whether it's cellular, or whether it be another 900 megahertz solution, like a CalAmp radio. We have installation kits for all of those, and you can implement those radios, take advantage of the battery backed up gatekeeper for the radio as well. Great, thank you. So some things to think about as you're implementing WAN technology. First of all, obviously, what's available in your particular area? What kind of cell coverage do you have? And is that the most economical choice for you when you look at your machine-to-machine data plans for backhauling data from your gatekeepers back to the head end? A very significant consideration. Are you leveraging anything else that you have in terms of whether it's distribution automation or any other WAN technology that you may have? In some cases, you're actually providing ISP, types of resources to the village. Are you taking advantage, of that WAN technology? You can also implement media converters within these cabinets, right? So if you want to go from fiber, or if you want to put in, a Wi-Fi connection to your gatekeeper, all those are possibilities. The cost per meter that's served across your LAN WAN, and HAN infrastructures is very important. What is the actual cost of your data plans for machine to machine? What types of security are you concerned about? Installation, training, and staffing are all questions about what WAN technology you're going to look at. So all those will be part of your overall business case for determining your WAN solution. And of course, regionality. The main message that I'd like to provide for you is that one of the reasons Elster created this very universal gatekeeper to pull information in from your meters with lots of different WAN options is strictly because of customers like yourself who have a very difficult and challenging case on the ROI when it comes to implementing WAN technology. All right, so what is it, we talked about at the beginning of this, which was, improving your overall quality of service, improving your customer service in strictly metered cache types of applications. That's kind of the baseline. That's where we begin with AMI, with advanced metering infrastructure. But now you've got a very intelligent distribution network because you've got metering points throughout the network. That changes the game a lot. Not only does it help you, right, improve your overall meter to cache, but now you can be starting to think about more advanced applications, things that you couldn't do before. For example, even in improving service, what about theft and tamper detection? Now, since you're actually monitoring the network, you're monitoring the voltage on the network, you're monitoring these meters, you're getting a lot more real-time information to improve that quality of service overall. So we take care of, with really good infrastructure, the basics of meter to cache, the basics of monitoring your network, so that you can start to think about what else can I do in terms of advanced load management, outage management, et cetera. Those are the kinds of things that you can start to think about once you've got core, really great AMI technology in place. All right, with that, I'm going to turn it over to Gary to talk about those more advanced applications. Thank you.
Hi, we can open up for one or two questions for Jim first, if folks have any questions. I actually have, one right here. Hold on just a second.
Just back to the summary page, we all know that cost is probably the biggest issue in rural Alaska. Are you seeing a cost savings? Can you elaborate on that?
So, obviously the business case for implementing AMI, I can't think of a better payback than in Alaska, quite frankly. The cost for you to get feet on the ground, and when you look at one flight out to a remote village, that's going to pay for an awful lot of infrastructure. I mean, I think no case have I seen in anything that we have done. And it's true right here in Alaska today because AVEC, as you know, has implemented Elster's AMI solution, for 40+ villages. And, they're seeing those kind of paybacks now where, they're able to do remote connects and disconnects. They're seeing that payback now where they don't have to send somebody out because they've been able to pull a real-time data feed. So when customers, and unpredictably, right, at any time of the month and so on and so forth, they can do a real-time billing based on the information there. So whether it's the actual reading of the meters, whether it's managing those meters, whether it's managing the distribution network itself, when you have real-time monitoring so that you know what's going on all the time, when you have real-time data to understand and see what's actually happening, just even from a registers and a usage and demand perspective, you're eliminating an awful lot of trips. So obviously you have to do your own ROI on this, but the business case is overwhelming, quite frankly.
What's your product offering in the competition?
Who's our competition? Is that the question?
What's your product? What is your product offering that the competition doesn't?
So one of the things that we're offering is the 900 megahertz technology. Right now, some competition offers that as well. I think one of our most significant competitive differentiators, and I spent a little bit extra time on it within this presentation today, and that is our universal gatekeepers are a real big competitive differentiation for us because we can put in pretty much any type of WAN technology that you want there. We also have the cellular-based meters, another big competitive differentiation for us. So in those places where you have to do some spot fill, where maybe the 900 megahertz solution isn't reaching all of it, you have some isolated residences that are just way far out, but you do have cellular coverage. From an economics perspective, it makes most sense to implement the 900 megahertz technology for the mass portion. So you had a village of 400 people, and you have 10 outliers. Really outliers. You'd put in the mesh technology to catch the 400, and you put in maybe 10 cellular meters to catch those others. And now you still got one basic system. Everything operates and works the same, but you've used different technologies to bring it in. That's a big competitive differentiation for us.
All right, thanks, Jim.
Okay.
Yeah, Jim, I actually have one other question for you on your meters and the data resolution. What kind of resolution at the residential level can you get? Is it hourly, daily, and then also can you detect power quality issues remote out the system that you may not be detecting at the central power plant?
So if you want to do 5-minute interval data, you can do 5-minute interval data. You have to look at the value of bringing that back, right? And the cost of bringing it back across your WAN solution. But ultimately, if you want to get that granular, you can get down to 5-minute intervals. And the second question was?
Can you monitor power
So PQM is something that's available on our commercial industrial meters. So if you want to do power quality measurements, on our industrial meters, you can bring that information back across through the energy access system, through the radio network from our commercial industrial meters. Something that's close to that power quality would be the 6 values of instrumentation data that you can pull off of our REX-U meters, which is a residential-based meter with cellular connection. And again, you can pull instrumentation data off of that. That gets pretty close to PQM.
Thank you. All right, next up is Gary Moody, and Gary's with Utilismart. He's their VP of Sales and Marketing, and he's an electrical engineer who, he's from Michigan, and those in Alaska know that Michigan is the other state that shows you where on their hand that they live. They'll always show you this. There's only one problem, and that's if you live in the UP. It's like, it's not on the hand. Well, Gary, do you know how we do it in Alaska? State of Alaska right there, and you can see the whole state. So anyway, he comes from the UP and went to Michigan Technological University. He's been involved in the utility industry for more than 20 years, and this is his first time to Alaska. So let's give him a welcome.
Thank you very much.
This is just going to be...
Sure. So this is my third time to Alaska, once a month for the last 3 months. So I will see you once a month for a long, long time. I like it. It's cold here. I like the cold. The Upper Peninsula is very cold. 275 inches of snow a year, and it was a good time. I like it a lot. Okay, I'm here to talk to you about the cloud, the Internet cloud. How many people have heard of the Internet cloud before? Everybody? iCloud users out there? Okay. How does that affect us in rural Alaska? You notice how I included myself with y'all. Okay, so that's what we're going to talk about. Like most companies, we have a vision statement that is to solve your problems, the ones you have today and the ones you will experience tomorrow. And just a little background on our company, 14 years purely in the utility industry. The ground zero for AMI, smart metering, smart grid, is Ontario, Canada. Ontario, Canada went automated meters with 5 million people over 10 years ago. The government mandated it. We have a sister utility, Essex Power Lines, about 28,000 meters, and they had to go through this regulation. They said, we have no idea. We're busy enough doing what we do, and now our government is thrusting this on us. How are we going to get there? And from there, our division, Utilismart, was born. And so we literally helped our sister utility launch everything Jim just talked to you about. And in fact, after extensive analysis, we did decide to go with the Elster solution. So our sister utility uses the Elster, and my company, Utilismart, actually runs that and optimizes that network for Essex power lines. After that, we went on to do this for many, many, many utilities in the province of Ontario and then throughout Canada, and now we're bringing that technology to the United States as the United States has embraced smart metering. We have already seen it, we've lived it, we've seen your future and it's bright, and we help you get there. One of the critical things about the cloud is, you might have heard recently that some of the movie stars got a little bit in trouble with their iCloud. So how safe is it, right, and security? So one of the things that's critical for success is certifications. We are ISO 27001 certified. This is something that's critical for you when you're finding a partner to meet your security needs with NERC and FERC and SIP, and it gets really crazy. In fact, there's a lot of reasons why the cloud is important to you. But we actually then host up the software, and we do something called software as a service, or SaaS, software as a service. And that includes a lot of things. Jim, on his slide, had a software application, the head-end software, and we actually host that up in the cloud along with a huge hard drive in the sky for you. But the cloud computing, what it does is it brings you a tremendous number of benefits, including money. So our friend there asked about money. So if you wonder why Google and IBM and Apple and all these people are running to the cloud, it's the most effective, efficient way to implement their solution to us. And so Utilismart has implemented cloud-based in our utility space, like I say, for 14 years. And it brings you all of this information. I was working recently with AVEC. AVEC is interested in testing some of the remote villages. They're having trouble with that cellular connection. They have some ideas. We can literally turn that on in less than 1 day. You cannot do that if you want to try to install your own servers, go to your own data center, install your own software. You just can't do it. We can turn that on in a single day and do a lot of testing. So just the timing alone is reason enough to save you a bunch of time, effort, and money. Anyway, what do we do for the utility? We literally become an extension of your company. How many people here are just walking around looking for things to do during the day? Does anybody have extra time on your hands? They got you pushed pretty hard today. You're wearing a lot of hats. You're busy enough. Now, instead of getting meter reads once a month so that you can get the bill done, so that you can get PCE and all this other stuff, now we're going to go to hourly data collection. Are you kidding me? How much time do you have to do hourly work now? So this is where you reach out and you get a little help from your friend. We actually, that's the core of what we do. For over 100 utilities, we read their meters for them. We become their meter shop. And when we're talking about payback and money, you'd have to have a pretty deep IT staff. You'd have to have a pretty deep staff to do a lot of this stuff. AVEC has that. They are actually looking at going away from the own and operate and going to the hosted model. Why? All those efficiencies that we talked about earlier. Plus, the connectivity to rural Alaska is brutal. I got to tell you, it is very, very challenging. And AVEC has an amazing IT staff, an amazing system. You'd be pleased to have access to it. They have about 56 remote gatekeepers that they got to call once a month, and they have a bank of modems. I haven't confirmed the number, but I know it's less than 10. And that bank of modems, their job is to call those 56 devices and get all the data, and it is a challenge. And what Bill Thompson has told me often is, I'm going to teach about Alaska, kid. You know, so okay, Bill, help me understand your issues. So one of the things that he was surprised to know is we have a bank of about 53 modems, and we call thousands and thousands of meters every single day. So we have quite an expertise in calling modems and modem strings. It's an art, actually. And so when he heard we had that many modems, he wanted access to that pool of modems. And then the other trick is we call those things every single day. If they don't, we call them again. So all our modems are about dead from 1 a.m. to 8 a.m. They do all their work, and then they lie dormant waiting for you to call. So we're going to be able to really free up a lot of the AVEC time, actually, by using our modem banks and some of the secrets we've learned to connect to remote cellular, remote areas. There's a lot of tricks you can do, and we can introduce all that and bring all kinds of good readings to that. So we actually do the meter collection. We then clean that data. We actually have a full-blown MDM, meter data management, an application that will cost you $500,000, an application that will cost you $300,000 to $400,000 to implement. before I go on, does anybody have an extra $1 million lying around for an MDM? No? Nobody? Okay. Yeah, so for pennies per meter per month, we give you the clean data. So we read the data for you. We then clean the data. We securely store the data, so that all you have to do is log in through your browser, and then we present that data to your billing system, to your outage system. Connie's going to talk to you about a Prepay system. We can hand it to the Prepay system. So we are the center hub for all of that information, getting it from point A to point B. Some of you carry around a smartphone. We have a smartphone app. It'll give you announcements from the utility out there. Hey, this Friday is, the party at City Hall, or whatever you want to do with announcements. So that's all the items we do, and there's lots of ways we do it with lots of different servers. It's not just a single server. There's actually 3 of them, and there's just a ton of infrastructure of what we do for you to help free up your time and your day. And we are also able to then transition from what you currently have, foot reads or car reads or whatever way you're currently reading, into what Jim described earlier. And I thought what I would do is talk about maybe what happens now. So you get the data. This is your AMI network, what we're going to in rural Alaska. So either AMR to AMI, the transition, or a full-blown AMI system, whatever way you want. The point is it's all turnkey. It's all sitting there ready for you. What I wanted to show is go back to your villages, and I don't know how you're getting your reads right now. It doesn't even much matter to me. I wanted to talk about how the reads would come in under the system that Jim described. So he went into depth about the mesh. Pretty cool. Meter to meter to meter to meter, 900 megahertz, free spectrum. It sort of happens for you out there. It comes to a takeout point, which is connected to the internet. So let's take a look at all that data moving around. Are you ready? Whoa. Anybody dizzy? Thanks. Took me a while to draw that slide. Back it up and show it again. Okay, here we go. Everybody, but seatbelts on. Woo. What do you think? Pretty cool? All right, I'll sell that for $1 a slide after the show, okay? All right. What do you do with that data currently? You create an invoice. That's basically what you do with it right now. All that data, and you create an invoice. And what we would like to do is show you how to take that data and do a whole bunch more with it. So we not only create the invoices for you, we can do all kinds of analytics. For example, we can show you where your meters are on a map, for example, and you can click on it and take a look at what's going on. We can show you voltage issues. So we sample the voltage. We pick certain meters in the village, certain meters off transformers, and we bring that information back often, and we talk about voltage issues that you might have. We take a look at transformers. I don't know how many distribution transformers you have, but we know what the transformer is. We know the loads connected to it, and we know that those loads should add up to less than the 25 kVA transformer feeding it, for example. So we would help you understand where your overloaded transformers are and who is actually overloading that transformer, right? We also are able to put the transformers on a map and tell you which transformers are overloaded. Anyway, lots of cool stuff. Network loss analysis, power theft analysis, tons of cool things coming out of these meters now instead of just kilowatt hours consumed. So we have hourly consumed. You're running a generator. We can match all that up against the generator. Talk about when the generator's being run the hardest, the most, the least, when you have free time. Bunch of analytics that can be done on this stuff. Really fun stuff. All right. Having trouble here. Okay, last slide I want to talk about is the infrastructure. So you got some 3-phase meters out there, you got some single-phase meters out there, and what we are doing is we're bringing that data into our system, and we're cleaning that data through this engine. We're storing it in a database, and then we're sending it out to all of your utility applications, outage systems, prepay systems. We're running reports for you through these modules here. We're also able to bring in other utility sensors. So if you wanted to bring in some generator information, if you wanted to bring in, maybe you're going to hang some fault current indicators off of transmission distribution lines, reclosers, transformer monitoring packages. You pick whatever you want out there on your system. We will bring that data in, clean it, store it, put it on a map, and start doing some analytics on it. This Consumer Energy Manager is quite interesting. It's actually a smartphone app and a web portal, and we demonstrated this at AVEC. They were pretty excited about the possibility of sharing information with their residents. So right now, you know, you got Facebook and Twitter and everything else. A lot of the states, the lower 48, they're getting in trouble. The people will start up a Facebook page and use it against their utility. I don't know if you have that challenge up here or not, but a lot of rumors get started. So you got somebody will fire off, and then it's on fire, and before you could even catch it and put some realistic thoughts on it. So this particular consumer energy manager is nice. It's a direct tool that the utility can use, a notification engine that you are in control of, so that you can actually communicate back and forth with your residents through a controlled mechanism. Also, if they see something that's going on out there, let's say they see an outage, they can actually report the outage right from their smartphone. So they're out there, they see it, it's due to weather, are their neighbors' lights on, yes or no, they send it back, and you have a one-on-one dialogue with them through this consumer energy manager. It's a powerful tool. It can integrate with your Prepay solution that Connie's going to talk about. It can tell your residents how much they've got left on their bill. It can tell them how much they've typically used every November in Alaska. It can tell them last month to this month. If you wanted to implement different pricing plans, it can help them compare the pricing plans. I don't know if it's applicable, but just a bunch of stuff that consumer energy manager can do for you. So again, we bring all the data in, including from other sensors, clean the data, store the data, send it out, present the data on a map, consumer reports, and analytics. That's fundamentally all the things we do. We do that on your behalf with you. We become your meter data collection so that you can be free to do other things. It gets more complicated. Instead of collecting data once a month to do bills, when you start bringing in hourly data and you start to try to really leverage the infrastructure to do some cool stuff, you need some tools, you need some help, and we're here to help a lot of the smaller utilities. A gentleman asked a question, why is Elster, what are the advantages? There's an organization in the municipals, in the lower 48 there's the municipals, and very similar profiles to what you have here in Alaska. There's a group called Hometown Connections. They do a lot of independent evaluating of different systems, and they partner with what they believe their customers should look at hard and use. And Hometown Connections, after all their analytics, has settled on Elster for years now. So Elster is a friend of the small community, and that's right where we want to stay as well as Utilismart. We want to help the small community win. We want to show you how to leverage the cloud. I've had some pretty intense IT conversations with AVEC. They have a very deep staff. Sherry's pretty tough. I don't know if you know her or not, but she's really put us through some ringers, and we've come through in flying colors. I'm proud to tell you. There's 3 from Seattle, 3 lines that go underwater, and 2 lines are down a lot. And anyway, we've done a lot of intense testing on the backside, and it's come up with flying colors. It turns out that you're connected to lower 48 internet-wise more than what is commonly known. And with our data center being part of North America, we are performing in aces. It's really, really cool, the tests that are coming back with time to lives and pings and all this other stuff that's on the IT side. So let us help you as this new technology comes. Let us turn this data gathering labor of love, let us turn that into some real world information for you to make some decisions to run your utility more effectively, free up some of your time so you can, I don't know, fish maybe. Does anybody like to fish? I hear there's fishing. I'm supposed to go out and I have for rainbow trout or something like that, and we have a guide. Her name is Dolly Varden, so I'm hoping she's a good guide. So they claim she knows all the good spots for fishing, so wish me luck. That's, you know. And any questions before I turn it over to Connie? Not strictly, no. We are Elster Managed Service, though. They've done an analysis of similar companies like ours, and we are under the covers Elster. But no, we are able to accommodate other technologies into our world as well. You bet. Any other questions? I'll be here afterwards.
All right, next up is Connie Fredenberg, and she's going to talk to us about more the metering from inside the home perspective. This all has been good information of how the utility can look at the system and see how it's operating, but there's also real benefits to the ratepayer of looking at how their system's running, understanding how they're using power, how much they have left at the end of the month, and it can actually drive behavioral changes. Connie's got a great history in Alaska. She came up here quite a long time ago on a post-college project and ended up staying. She was up on the North Slope helping out was it U.S. Naval Office? Yeah, Naval Arctic Research Center. She's lived in Point Hope for a long time, and she's also been a muskox wrangler. So she's got some pretty good bona fides here. And these days she's got a company called Utility Management Assistance. It's a small business that works with the rural electric utilities on teaching them how to train up on their reporting and basic management of utility. And she also works with Marsh Creek to install and provide technical assistance on the AMI prepaid electrical meter systems. And that's what she's going to talk about here today. So give her a warm welcome.
All right. I do see a few familiar faces out there. And for you folks, you'll realize that I didn't make this presentation. I use a lot of pictures that I could talk about. There's a whole lot of words on here that I just got 30 minutes ago. So forgive me if I don't go through it as smoothly as I might. And the reason that I have this presentation is Clarissa Quinlan, the godmother of prepay metering in Alaska, wanted me to talk more about where AMI prepay metering is going. I'm really familiar with where it is right now. We have installations in 40 villages throughout the state, and these are with small, independently owned electric utilities. And the AMI system we currently use doesn't require internet. It's real-time monitoring so that people in their homes see exactly what they're using right at that moment. It's very useful for them. And meter reading is a job, so they like having a meter reader. It's another job in the village. But it only works in small villages because as your PCE rate changes, it actually requires a physical card that you have to go around and swipe through that customer information unit at the house. And so for larger utilities, it's not practical. If you're going to change rates, you would have to physically go to every house. We seem to focus on villages of 500 and less. But it appears that AMI, which started out in the United Kingdom, was then sold to Landis & Gyr, and then Landis & Gyr was sold to Toshiba. So they've added more features to the prepay system. Okay. See if I do this right. Okay, oh, there we go, yeah. Landis & Gyr is a global leader in smart metering, and they've been doing this prepay thing since 1962, but that's from the AMI company. They've now started doing this grid stream, which is something, I think it's the mesh that these gentlemen were speaking about. And they're committed to improving energy efficiency and environmental conservation. And prepay, I tell you, there is no more valuable tool to learn to conserve energy than watching your money go backwards in real time. So prepay metering really works. And that real-time information is the key. I was listening to you guys, and it's like you could get 5-minute intervals. This is like immediate. When you install this in someone's house, I tell them, go turn everything off in your house. And you can see that you're using about, I don't know, in a rural household, maybe 9 to 11 cents is what your power is costing you, the background things. And then you can turn the electric dryer on and watch it shoot up to $1.09. There's a clothesline outside that house the next day. We go through lots of appliances in the home to encourage people to see what it is that's eating up their dollars. And it does change behavior almost overnight. Okay, but it says it supports time of use and complex rate structures. Well, we don't have that in rural Alaska. Other than complex rate structures, you've got PCE and when you run out of PCE in a month. And it'll show you that right on the customer information unit as well. And we can also add the other like flat rate services, water, trash hauling, sewage, cable TV, you know, things like that can also be collected through the Prepay system. Accommodations for various methods, means of payment. People go to the utility office and pay with money orders, cash, or whatever in villages, but with these, Salt River Project in Arizona also has prepay meters installed, and they have kiosks where customers can come and pay with a credit card. So it can be upgraded, you know, for larger communities. So this is the system we use. It's got the meter, which is just a standard meter that goes on a, we just pull off the old meter and put this one on, and then plug that customer information unit into a wall socket, and it communicates through the lines in the house. And then the card is what carries all the information. You take the card to the utility office, you give the clerk some money, she swipes your card and puts the money on the card with her card writer. You take it home and run it through that customer information unit, and now all that information gets transferred to the meter so that the meter knows how much money you've got, and you start counting backwards. So what the next generation, though, is going to do is allow this system to work in larger villages, because there will be real-time two-way communication, meaning that you don't need that card anymore. You could just go to the utility, pay, and it automatically transmits to your meter, and the utility could then also change rates remotely. You don't have to have that card. So that's where the next generation of prepay is going to work in the larger villages and urban Alaska. So we started installing these through Marsh Creek in 2005. St. George Island in the Pribilofs was our first community, and now we have 40 communities. It immediately fixes cash flow. It's so hard to collect from your family, relatives, friends in a village. It's hard to go turn their meters off. But with prepay, you don't have to. They turn them own selves off by not putting more money on their meter. So, and we can add arrears to the account so that it'll take a percentage off every payment that goes towards arrears. And like I said, they disconnect themselves by not paying. All they have to do is go to the utility and put more money on, and the power comes back on. They're really easy to install. There's no hard wiring. It's just changing out the meters and plugging in the customer information unit. There's no collection hassles ever again. The customers love it. A lot of villages have installed them when they had some problem customers. In fact, one village only wanted 15 meters. They were willing to pay for the expensive office equipment just to collect from these 15 difficult customers. And those customers, of course, were a little upset at first. Why were they being singled out, you know, but they got it, and then they started to realize how much money it saved them. And they started telling their neighbors about it, and their neighbors went to the utility and said, I want one of those. And the utility wasn't willing to pay for them because they said they couldn't afford them, so the customers bought them for themselves. For $360, you could buy a set, the meter and the CIU and a card, and then they installed them themselves on their own house. Well, they had the utility install them, but they paid for them because they realized from watching their neighbors how much money they could save. And they did Aleutian Pribilof Islands Association did a study after the first installation in St. George, and everybody really liked them. Nobody doesn't like them. There's just this is one of my slides. The customer goes to the utility clerk, gives the clerk some money, they put it on the card, you run that card through the device at your house, it communicates with the meter. Now, the only way that information gets back to the utility, though, is through the card. When the customer comes back to the utility, that's when the utility then knows what's, how much usage they've had. So we do read meters. And the PCE program insists that we read these meters every month. So we didn't eliminate a job, but there's no billing. Prepay customers don't need to get a bill. It's just a regular meter. That 4 kilowatt hour rate registers means you can have up to 4 different electric rates. And the tamper detection is, if you mess with your meter, if you tilt it even 25 degrees away from the house, your power goes off. And the only way to get it back on is to get someone from the utility to come there, and they bring this laptop and they can hook it up to your meter and go, oh, you tampered with it, didn't you? And yeah, there's no getting out of it. You're caught.
Did they say it in that tone of voice?
I do. And you can, the best thing is they have these friendly non-disconnect periods where anytime that the utility office is closed, holidays, after hours, your power won't shut off if you run out of money. But 15 minutes after the utility office opens the next day, your lights go off. And it does keep track of how much you used during that interval so that when you put your card in with your next amount of money, right off the top comes what you used overnight or over the holiday or the weekend. And they can be, they don't have to be prepay meters. They can be regular meters, but nobody uses them like that. That's the customer information unit, just plugs into the wall. And the best part is, as a customer, you get to look at how much money you have remaining. After it gets to know you for a while, it'll say, well, this is how many days, considering your usage, that money's going to last you. It tells you how much your cost is per hour, how much you paid today, how much you paid yesterday, this month, last month. And the most important one is exactly what you've got on right now, what it's using. And there's an emergency credit code. If something happens, that computer at the office is critical to writing cards for customers. Well, what if the computer crashes? Oh no, what happens? Well, you call us up and we give you an emergency code that you type into your customer information unit, and we can just keep you going on that until they get the computer system back up. So there's no disaster if the computer crashes. Oh, and it goes off. There's a low credit alarm that once you get down to, and you set this, the utility decides $10, $20, and whatever that limit is, then your device will start to beep in your house to warn you that you're getting low on money, you better go put some more money on the card. You just have to push the blue button and it'll stop doing that. Oh, here, this is now part of the, no, this is still the same thing. This is all what we've already talked about. There's a lot of redundancy here. Oh my. Okay, Salt River Project. That's the large utility down in Arizona that uses prepay metering. And I actually went there. I have relatives there that use prepay. And it was originally put in for, as our small villages, for people who don't pay their bills. And they were constantly having to go disconnect and reconnect. So they put these in 5,000 homes that were problem customers. They now have, oh, I haven't gotten to that slide yet, but it's about 150,000 of them installed, and it's by word of mouth. People who were neighbors of those people liked them, and so they've installed almost 150,000 of them now. And this is a really large utility, 149,000. And it all has been voluntary. People request to be put on this system. And they do have those pay stations, which I just love, but I realize that's not coming to small town Alaska anytime soon, but the larger villages, that would be a really good way to do this so that people can recharge their cards at the grocery store. You don't have to go through the utility office. And as you can see, they had a really hard time at Salt River figuring out how to incorporate this into their traditional utility structure. But they get all their information not through the customer cards coming back to them, but through those pay stations, the information gets back to the utility itself. And their customers are all very happy with it. And this is why. It's a really good way to control how much you spend on power. If you're getting close to the end of the month and you don't have another $200 to put on your electric bill, you turn things off. And it's a good way to, you only use what you can afford. So the reason they want to advance this is because of Salt River Project. We are such a small peanuts to this company. Our meters in Alaska account for just a minor blip in how many of these things they sell. So they're not really interested in what we want, but they are interested in what Salt River Project wants, which I think will help us in Alaska because larger villages can use these and even the urban utilities could start using these now. Oh, right. They, Salt River Project, because they already have a lot of these meters, they didn't want this to be a whole new product. If they improve this to make it like these other smart meters, they didn't want to have to buy all new equipment. So Landis & Gyr is working with them to modify the meters that they already have so they don't have to go out and buy all new equipment. This is the complicated slide about how this will work. Everything talks to everything else is what I would say. But by 2016, that's when they believe this will be all ready for prime time. And they're going to have a new customer information unit that looks like it's smarter than the little one that is installed now. And Zigbee. What the heck was Zigbee? I didn't know. She said that's when it can actually work with the appliances in your home to, like say your freezer. It doesn't need to be on all the time. It can turn your freezer off for a few hours a night so that you're not wasting electricity on that appliance. Yeah, that's a little scary, I think, but. And that's that. So if you have any questions or want to order these, you can call me or Susan Gray at Marsh Creek.
And we'll open up to some questions for Connie, and then we'll kind of do general panel questions if there's some more that people have.
Your closing comments about Zigbee, sort of curious, what is the degree of separation to the next step where you start getting consumer information about how much energy I use, what appliances are using it, more information for the consumer? Is that even an option, or is this utility scale, or is it going to come into the house? Like
that's supposed to be in your home. That's part of the in-home display that right now just looked like the little tan box, you know, with one little item of news, and you had to push a button to see it. It's that little thing that looks like a iPad. So it is in your home.
In fact, I think one of the features of Zigbee 2 is, especially like for Salt River Project, they have time of use metering, and so at different times of day, you'll have some kind of a deadband area on your refrigerator and other appliances, and it can wait until it's a more cheap time to actually run that, as long as you're within the tolerances and you're not letting meat thaw out in the freezer, those kind of things.
Now, has there been a study, or I'm sure there has, what's the average consumption reduction when a household receives one of these? You say everyone conserves power at that point. Is there any numbers on that?
Salt River Project did a study and showed that 10% was the amount of consistent reduction. What we noted, and we didn't do an official study, it's just, you know, observations. In every village we installed them in, Within 24 hours of the installation, the village load had dropped by 25%. It works its way back up, but never to the level that it was. It's always at least 10 to 15% lower than previously. So it's significant. It's almost like installing a wind turbine.
Connie, I think you could talk to this because of your knowledge of PCE system and assistance with the utility managers. But let's say your local village, the utility says they can't afford to buy these, but your local, some of your local residents do. It's better for them to buy it through the utility, and then the utility can take a portion of that cost and write it off as a PCE expense, versus if they just pay for it out of their pocket, they would be paying the full amount. Correct?
Correct.
Yeah.
Correct.
So,
yeah. Well, and you can't just buy a set of meters for your house. You know, the utility has to purchase all of the computer equipment for the office. But a lot of villages have gotten them through grants, through like their Economic Development Corporation. They've purchased a few, but then the utility doesn't get to count them for their PCE, but the utility couldn't afford it otherwise. So.
Connie, under the circumstance where someone runs out of money and they're facing a freeze-up situation, have you encountered that thus far? And is there a protocol for that? And is there any legal ramifications with not supplying power so they don't freeze up?
Well, I'm probably not supposed to say this, but what we do is in the winter, when we see a really cold spell coming in some villages, we call up the utility and say, hey, do you want us to put them on non-disconnect? We don't tell customers that. Oh dear, I'm just telling. But we do that so that nobody does freeze up. Plus, another thing we're always worried is that the contactor that opens and closes, it's only tested to 40 below zero. And a lot of interior villages get colder than that. So we're afraid that even after they put more money on, they'll have to take the meter in the house and thaw it out before they could, you know, get the money into it. So we do, when it's going to be really cold, we put them on a do not disconnect just to prevent any problems.
I think we can open up to more questions for the entire panel on metering. One comment I'd make too is I spent 17 years at Intel Corporation, and one of our credos was don't collect data unless you're going to analyze it, and don't analyze data unless you're actually going to take action on that analysis. So this is great stuff, but you can find yourself swimming in data. Now, every small utility that I've been able to get the data, I do spend time looking at it, and we always find something that, hey, here's an issue that we could be improving, but we tend to start at kind of the hourly level of data, and then as we see issues, we might focus in and get the higher resolution of 5-minute or 1-second data, but then we'll pull back out, so we're not always dealing with gigabyte-sized files of 1-second data when you could probably detect your problems elsewhere. But anyway, I'll open it up to other questions for the panel if you have them.
I'm Steve Sherrill with the Northwest Arctic Borough School District. If I cut my electrical consumption by 50%, my rates are going to increase by 50%. It's because they have they need that kind of money from me. I'm the largest consumer in the village. The villages in Alaska are diesel. So you can talk about electricity all day and kilowatt hours, but until you save me a gallon of diesel, I'm not saving a penny of money. And right now I have no solution for that. And I was hoping to get that from, it's rural Alaska. We're not on the grid. I have no solution to monitoring and metering my diesel consumption. And you could talk about electricity all day, and I can save electricity all day, but I'm not going to save a penny. And I'm wondering if you see anything in the, if your industries are looking at all at diesel fuel oil.
Clarification, are you self-generating out of your school?
No, we're prohibited from self-generating by our electrical utilities when we sign the contract on.
Okay.
So I can't, I would need an arbitrator between me and the electrical provider to say kilowatts equals gallons. If I save, give me the money back. Right now, I get no money back.
Yeah.
No matter how efficient I become in my
Yeah, I think that's something you should definitely take up with the utility, because it wouldn't be just a straight, if you save a kilowatt, then whatever you had been paying on that rate per kilowatt, especially if you're a large user, you'd see all that savings. But you should expect to see the fuel portion of that kilowatt, because each kilowatt there should be a system to manage and maintain the equipment, the distribution system, and then you've got a portion that is your fuel. And if you save a kilowatt, that does have a real savings of fuel savings for the utility. So that is something that you should push back on, because, but yeah, you won't see the full savings, but you should have some.
Right now, I have absolutely no solution to monitoring my fuel oil consumption. And a lot of the grants are based on my ability to show the state how much fuel oil I'm saving. And I have absolutely no solution.
So again, Utilismart, we have a few other sister divisions. One of them is solar, for example. One of them is running generators. So I didn't show it on the map, and I went kind of quickly. But the PCE, we automate that process. We do very similar things, what's called settlement in Canada, for example. We settle the bill for the utility back. But I went pretty quick, and I apologize, but we do actually turn gallons of fuel in a generator and relate that back through the electric utility. So we have those, we have that married in a product called SmartMap. So we should talk, because that's exactly what our one division does, and it's all married through our software. Great question. Yeah. Absolutely.
And come speak to me too. I'd like to get some more information. Another thing, this brings up another topic too. Let's say you have some residents that might be putting solar PV or have a small residential wind turbine on your local system. It's important to understand your rate structure and how much of that is fuel versus the rest of the system, the operations and maintenance portion, because if you're just charging out by a flat rate and not breaking out those two components, the more energy they consume, that actually dumps the system's costs that aren't covered separated on your rate. It dumps those to the other users. So it's important to know those, how much is fuel, how much is the operations and maintenance. Yes.
This is just another question for Connie. In the system, do I understand that the meter goes on the central inlet to the house, but on the other side you said you could make a decision of whether the dryer was running or something? You must have something more than the one unit to make that decision. Is that true?
Right. The meter goes on the house just like a regular electric meter. It just replaces the existing meter. And then the customer information unit, that little tan box, just plugs into the wall. And that's what you look at for what's actually going on. You know, that's where you scroll through a menu to see what you've got on right now at the rate you're paying is costing you. And
is that hooked up then to the panel then? Does it know what particular line is going to the dryer, is going to the refrigerator?
No, it's not that sophisticated yet. It's just the whole house's usage is what shows up. You have to actually turn everything off and turn one thing on at a time. Yeah.
To clarify, that was my question previously. Is there a plan for getting any of those technologies into the house so consumers can start assessing? So yes, okay.
The future AMI is going to have that, it looks like.
And newer appliances, as they get shipped out to these communities, they'll have these Zigbee available features on them. All right, I think we can wrap it up. Thanks everybody for coming. If you need continuing education forms signed, you can bring them up in the front. As you go out to the sign-in desk, there's feedback forms for what you loved and liked, and maybe we could have done better about the session. And then I think we've got a break until 3:30. So thank you for coming, everyone.